Hi class, this is section 9.1. We're going to take a look at lines, angles, and circles. A lot of definitions in there. So let's start off with our basic definition of lines. First of all, this is a line. Here's a point on the line, that's point A. Here we have a half a line, which is also known as a ray, but this A is open, and so it's just a little bit difference between a ray. So notice it starts at a dot, and then it goes off and has a nice little arrow here, and then it goes off in one direction. And then, of course, line segments have two dots on each end, so it actually is a fixed line. It doesn't go on forever. It's called a line segment. And then parallel lines are defined as two lines in a plane that do not touch. Notice it's like they're on a piece of paper. That's called a plane in geometry. If I was in person, I would be showing you this piece of paper and moving it around. But this is an actual plane, and these are intersecting lines. Here's another intersecting line. These aren't perpendicular lines, they're just intersecting. Okay, so some basics there. Angle basics, we've got to know when we talk about angles, we have an initial side. This is where it starts. We have our BA, and what happens is this angle opened up. So if you can imagine this line right here kind of worked its way. It was down here, and then it just kind of creeps up to be the actual full angle itself. And so this is called a terminal side. If you think of an airport terminal, that's where the flight ends. Terminal means it's going to stop. Okay, and then this is also identified as our vertex. If we take this angle and if we continue to open it all the way around, we'd get this picture over here. And this would be our initial side opened all the way up, and then our terminal side came here, and that makes a full revolution, which I'm sure you've heard before is 360 degrees. So this would be a picture of what just 36 degrees looks like. This is 1/10 of a complete revolution. So in other words, if I had 10 more of these lined up, well, that wasn't a very good one. So if I added up 1, 2, 3, 4, all the way around to have 10 of them, that would be an equal amount of this 360 broken up, that I'd have 10 of them. That's what this picture is. And we've got a wonderful protractor there, which is kind of hard to see. But if you use a protractor, if you have one at home, you would put there's a line right here where you can have, it's like a nice little T, upside down T, where you would put the corner of the angle, you start it on its initial side, put the dot there, and then wherever the angle points through, that is how big the angle is. But you got to be careful because you've got, it says 10, 20, 30, 40. When you're starting small, you're counting up that way. But if this was like a bigger angle, notice it gets bigger over here. So if my angle opened up like this, then I'm using these numbers on the bottom. But if I was measuring an angle from this side, then if I was measuring it from here, then that same angle would be that 110 rather than the 70. So it just depends on which side you're measuring from. If you're measuring from here, you count increasingly from the top, and on this side, you're counting increasing from the bottom. So here's some pictures for us. The 45 isn't the important part. The important part is the definition of an acute angle. Acute angle is less than 90. So in other words, if here's 90, if I have an angle that opens up to be anything less than that, we get acute little angle, acute. And then a right angle is, of course, 90 degrees. It's right. You put the little square in there to denote that it is 90 degrees. Obtuse angle is anything bigger than 90. So if I go open up past 90, anything just barely past, even an angle that looks like this right here, where it's just barely past it, is also called obtuse. And obtuse is like obese. I like to see obtuse kind of looks like obese. Is a very large angle. And then our straight angle is if you have a straight line. A straight line is defined as basically 290 degrees is the easiest way to see this. See, if you have a 90 degree there, you have another 90. 90 plus 90 is 180 degrees is how you can remember what a straight angle is. And of course, if you just keep adding, 90 plus another 90 plus another 90, that adds up to 360 degrees. And that's where the one full revolution came up, or how we came up with 360 degrees there. So vertical angles are an important property in geometry where if you have an angle here, and let's say this was 30 degrees, then this angle over here also has to be 30 degrees. And if these are 30 degrees, then there's also a special property that says if this is 30 here, then it has to add up with 180 degrees with this part. So this leftover part is 180 minus 30. In other words, 150 degrees. And if that's 150 degrees up there, then this has to be 150 degrees here, so that if I add 30 plus 30 plus 150 plus 150, I would get a total all the way around of 360 degrees. So the logic that I just used, you're going to see that a lot worked out later in the lesson and in the next subsequent lessons. But here we go. This one says if x is 86 degrees, find the measures of angles 1, 2, and 3. So basically what I just did a moment ago, I can throw 86 right over here because these are called vertical angles. And vertical angles are congruent. And what we know then is that this amount has to be 180 degrees minus what 86 would be. And that's because if I have 86 like this, then this leftover part has to add up to 180. So we say 180 minus the 86. And if we do that, we're going to get 94. So this is 94 degrees here, and 94 degrees vertically would also be 94 degrees there. And if I add all that up, I'm going to get 360 degrees. Okay, now we've got to talk about complementary angles versus supplementary angles. Complementary angles sum to 90 degrees, and supplementary angles add up to 180 degrees. In other words, if we have two angles that make, if I put them together, they make a 90. We call them complementary. If I have two angles like what we were just dealing with, and they add up to 180 degrees, we call it supplementary. Now, how do you remember the difference between the two? Well, you're at home, you can write it down and have it sitting in front of you. But I usually tell my students to pay attention to if we can spell. The complementary has one P, the supplementary has two P's. I don't know, that helps me out. This one holds, it's a smaller amount of P, and this one's a larger amount of P. I don't know. The other way that I've heard students is it's alphabetical order. C comes before S, and so 90 comes before 180. So complementary, then supplementary, if you remember which one's which. So you'll have problems, by the way, where PowerPoint froze. And we're back. So if we have, on this complementary angle, if I know that this is 49 degrees, because we know that these are complementary, I can take 49 and know that this leftover part, of course this is not drawn to scale, needs to add up to 90 degrees. So I can say x plus 49 equals 90. And if I subtract the 49, x would be equal to 90 minus 49. And so that leftover part of 90 minus 49 should give me 41 degrees here. And so this was, if this is 49, this leftover part has to be 90 minus the 49. And over here, as I did earlier, if this is 70 degrees, then this leftover part has to be 180 minus the 70. Okay, you'll have some questions like that in your assignment. Important things to note, you're going to have, this is a very popular concept in geometry, where these are, we call these parallel lines, and they usually put little arrows on them to note that they're parallel, but I think that in your problems they'll actually just state it. So these are parallel lines, and if you put these two little cool arrows on both of them, or three cool little arrows, or just one of them, it means that those two lines are parallel. And we're cut by a straight line called a transversal, so this is called a transversal. If this happens, wonderful things happen in geometry. Now notice that 7 and 8 have to add up to 180 degrees, and 8 and 6 have to add up to 180 degrees. So there's a lot of great things that happen here. What we're going to see here is that we've got a lot of corresponding angles. It says angles 1 and 5 correspond. Now corresponding angles mean that they have the same measure. Okay, they have equal measures. So 1 and 5 have the same measure, 2 and 6 have the same measure, 4 and 1 have the same measure, 4 and 5 then have the same measure because 1 and 5 have the same measure. So there's a lot of great stuff going on here, and there's names for these things. So 3 and 6, if I look at angle 3 here and angle 6, those have equal measures for a few reasons. You could say that, well, 2 and 6 are the same, so that means 3 and 2 are the same, so 3 and 6 are the same. So you can work at it that way. Or what we have is it's called alternate interior angles. In other words, if these are inside the parallel lines, these ones are all interior angles. So this is the interior. And they alternate from one side of the transversal to the other side of the transversal. That's called alternate interior angles. And whenever that happens, they're the congruent. So in other words, 4 and 5 are also alternate interior angles. Alternate exterior angles, if that's interior, then the exterior is the outside here and here, where these angles have special properties. If you alternate, like 7, and go over here to 2, those are going to be congruent angles, alternating, and they're on the outside. In the same way, 8 is going to alternate and be the same as 1. Okay, and so interior angles on the same side of the transversal. Sorry, I already talked about that a little bit. No, I didn't actually. On the same side of the transversal, so they're adding up to 180 degrees. So 5 and 3, if you added them up, that would add up to 180 degrees. Same thing with 6 and 4, that would add up to 180 degrees or supplementary. Okay, so what that's doing for us is it's setting up problems like this one, where you've got 20x and you've got 10x. And your job is to solve for x. Well, it's not leaving you very much, except it's assuming a lot. It's assuming that you understand that this guy, 20x, would have been the same as this one. Or you could have said it was the same as this one. Either way, if you put 20x right here, that means something special. It means that this is 180 degrees, so that means that 20x and 10x are supplementary. They add up to 180 degrees. That just made an algebra equation. So your whole job with these problems is to make an equation and then make this 30x equals 180 degrees by combining like terms. And then if I divide both sides by 30, that'll give me my answer
of x equals 6 degrees.
So then we have a more complicated picture here. So we've got a lot going on. It tells us, assume that L and M are parallel. So I could draw cool little arrows on those to show that those are parallel. Okay, so we'll keep that in the back of our mind. It says assume that angle A is 51 degrees, as is noted here, and then angle B is 76 degrees. Then we're asked to find a couple things. It says find the measure of angle 9. Well, that's interesting. Angle 9 is over there. All right. Find the measure of angle 2. Okay. Well, to do this, we've got to do a lot of building. And what we want to do is see that there's a couple great things happening. If we know that this is 76, we actually know a lot. Well, we know, by the way, this 12 and these 3, these are just measures. They're not measures. They're names, not measures. So what is important here is to know, first of all, that if I have 76 here, I can find angle 7. Well, why is angle 7 important? Well, if we ignore this line right here, what we'll see is that angle 7 is actually the same as 9 plus 10, or angle 9 plus angle 10. So that's important because if I know this angle, angle A, that's a vertical angle with angle 10. So that's cool because that means that this is 51. So if I know angle 7, this whole thing, if I subtract the 51 from it, I'll get angle 9. So that'll help me find A. So that's the method that I'm going to be using here. So I'm going to take and have 180 degrees. Apparently I can't write 8 today. 180 degrees minus 76. So 180 minus 76 is going to give me 104. So angle 7 is 104. That means this whole amount right here is 104. And if I subtract the 51 from it, so minus 51, the leftover portion is 53. That is angle 9. Excellent. Now we want to find the measure of angle 2. Okay, so measure of angle 2. Well, if I have 51 degrees here, and I have my rule about the interior angles of a transversal, what I have is I know that this and this should add to 180 because it's on the inside of two parallel lines, and there's just one transversal, so that the angle 2 and angle A, 51, have to add up to 180. So in other words, angle 2, so we'll call it T for 2. Make a nice T like that. T for 2 plus 51 has to add up to 180. So that means if I subtract 51 from both sides, let's do a little algebra here. So subtract 51, I will get T. T, angle 2, is equal to 180 minus 51, which should give me 129 degrees. So angle 2 is 129 degrees. Okay, so now let's literally turn, and talk about circles. Circles, the definition might be a little more complicated here than you've seen before. It's the set of points lying on a plane that are located at a fixed distance, called the radius, from a given point, called the center. And so here's the center of the circle, and then here's the radius. And the circle is denoted by a lot of dots that are at a fixed distance away from the radius, and that makes up a circle. Now in blue, around there, the circumference is what we call, if I start and take a ruler here and start measuring around the whole circle and get a total distance, I'd get circumference, so the total distance around the circle. And diameter is defined as twice the radius. In other words, the distance straight across the circle through the center. So it has to be through the center to be a diameter. Okay. So let's take a look at a problem regarding this. Angle that has its vertex at the center of the circle is called a central angle. So this is a central angle because its vertex is on the center. It's called a central angle. So it says the length of the arc between A and B is proportional to the central angle, angle ACB. So in other words, from here to here to here, this arc is proportional. And this, we can set up a nice ratio. In other words, it's this measure right here, the measure here, is a fraction over a fraction of all the way around, which would have been 360 degrees. So that's what is set up here. And that's equal to the length of arc AB. So you could also call it this way. You can put a little arc on it. That means arc AB. And divided by the circumference of the circle. So these are equal parts. The small part, the small angle measure, is on top of the small length, whereas this is the overall angle measure of a whole turn, and this is the overall distance of all the way around. So we have a nice little application problem here. So assume that a circle has a circumference of 12 meters. So all the way around would be 12 meters. Okay, the central angle has a measure of 120 degrees. So this measure in here is 120. Okay, so what is the length of the arc from A to B? So if we're just cutting off 120 degrees of it, what is this actual distance out of the whole 120? So we want to know what's the distance out of the whole, sorry, 120, I said it should be 12. The whole distance out of the 12 meters if we only have the 120 portion out of the total 360 all the way around. Well, I just set up a proportion to solve, and the way that I solve a proportion like this, when I've already got the D on top very nicely, is I just need to multiply both sides by 12. And then I can reduce, by the way, a nice thing with reducing with zeros, you can cross them off. So 12 over 36, you just multiply it in your calculator. So take 12 divided by 36, push enter, and then times that by 12, and you should get 4. So the distance, the portion that's cut off by the arc, is 4 meters. So that's the distance right here. Okay, so we have a little bit more complicated example here, a more complicated ratio. So we've got a circumference of a circle and the measure of the central angle ACB. So that's this angle here. We're supposed to find the length of arc BD. So we're supposed to find this arc right here. Well, that's kind of odd. We don't have that angle. I wonder if we're supposed to find that angle. But we are. So this is 9 degrees here. That's what we're told. That's that measure. And then it says the circumference all the way around is 480 degrees. So we're supposed to do exactly what we just did on the last problem, but we don't have the right angle. What we need is to figure out what is this leftover portion. If this is 9 degrees, and it's definitely not drawn to scale, we need to know what this angle is. Well, from the previous tools that we've gotten today, we know that this should be 180 degrees, so this leftover should be 180 minus 9. And if we do that, that means this is 179 degrees inside there. So that means I'm actually carrying about a 179 degree portion out of my overall 360 degrees all the way around. I only care about this part of it. Okay, so what portion is that? What fraction is that? And then I need to know that when I have my measure of the arc out of the overall total of 480 feet. So this is my total feet. I just want that little measure in ratio, in proportion to the size angle I have. So all I have to do is take my calculator, multiply 480 to the other side, and that will cause the m to be alone. So now I take my calculator and I can just multiply it straight the way that it is. 480 times, open my parentheses, 179 divided by 360, close my parentheses, and I got 238.67 feet is the part of the whole that gives us. So that's the end of this section. If you have any questions, please email me through the Ask My Instructor feature of the lab.